this computer. Okay. Before I say anything, you guys should know that today is our last class before the spring break. So that basically means this coming Monday, there will be no class, and we'll be back. Let me make sure just on 15th of March. So this week is a regular class week at Johnson County Community College. Next week is going to be the spring break. After that, we're back on the 15th of March. Now, when we come back from the spring break, we are going to have our midterm exam. So the midterm exam is going to be, I hate to say that, but it's going to be on March 15th. Now, what I'm going to be doing on Friday, I will send you guys a guide about the midterm exam, the format, what type of questions to expect, and how we're going to be taking that exam. So you'll have enough time to get ready for it. And if you have any questions anytime, I don't have spring breaks. I probably will be just at home. You can send me an email and I'll take care of it. So I'm going to send an email with this announcement, of course, later, just in case somebody missed it. So from now, you should know that on 15th of March, we will have the midterm exam, and also the first project will be posted on that day. Now, back to the class of today. Last week, we talked about repeating structures. Selection structures. And we said selection structures is basically a technique that we have in programming that will help us decide which instruction or set of instructions to be executed and which set of instructions to be ignored. And we said usually we use the selection structures to be able to make some decisions. And we spent the whole class last week talking about the if statement, the if else statement, the nested if statement, and then finally we ended up talking about the switch statement. Now today we are going to be talking about repeating structures. And let me start by sharing my screen. Now, before I jump into how do we use repeating structure elements or tools in C++, we need to have a really good idea about what is a repeat structure. Well, in general, let's just put an idea here. A repeating structure is the feature that you have in programming in general, where you can make your program repeat one step or certain number of steps for a specific number of times or unspecified number of times. So if I want to simplify that definition, is basically your capability to make your program repeat one thing multiple times. Now the question is, why would I need that? Well, there is a ton of reasons why you may want to need that. But just to give you an idea here, just for you to know what is repeating structures, why is it important? Imagine I want to show one message on the screen. For example, this is CS235 \n. Okay, so imagine, just imagine again, this is my line. I want to repeat this for 10 times. I want this message to be shown on the screen for 10 times. Well, if I have no idea what are repeating structures, my only option here is to do it this way. And I think this is 10, or a little bit maybe more than 10. But you can see here, again, even though I'm just telling you, this is not a really good reason why would you want to do this, repeating the same line, showing the same message for 10 times, but we have a lot of good reasons why we want to repeat something multiple times. But this is just to show you the problem with the technique that I'm showing you right now. This here is one statement. This is a very, very similar statement. And I'm repeating it 10 times. This is called redundant. I'm repeating the same piece of code multiple times. You should not do redundant in programming. In general, whenever you see yourself repeating something for more than one time, then you should know that, oh, this is not an efficient way to do that. So selection structures basically will give me the tool to do the following. Instead of writing the same statement 10 times, I can come here at the beginning, writing an instruction here, asking the computer to repeat this line for 10 times. And that's what repeating structures is all about. Now, you may think again, what is the point of showing the same message over and over? I will tell you, no, that's not basically why we do repeating structures. I'll give you some examples for now. And the example that the ZUI book is using is very, very helpful. And I actually have some experience with this example. And actually, this was an advice from a friend. Right after I had my second kid, he was a day sleeper. A day sleeper basically means he spent the whole daytime sleeping and he doesn't sleep at night. So my friend told me, just drive him around the block for a couple of times, and then whenever he sleeps, you go back home and sleep. So this is it. This is very similar here. I'm repeating my circulation in my block for a certain number of times. I don't know how many times actually. Could be 1, could be 2, could be 10, could be 100. It depends on what? When the kid will sleep. That's where I'm going to return. So repeating structures is very similar. You basically will have a condition here, an expression, a Boolean expression. And in this case, for the kid here, I will say, as long as the kid is awake, keep looping, keep repeating yourself, keep moving in the circle. And then until that baby is not asleep anymore, that's where I'm going to break the loop and go back home. So that's what looping is all about. It's basically repeating something, sometimes for a certain number of times when you know exactly how many times you're going to go. Sometimes you don't even know how many times you're going to be repeating the same thing, something. But you're going to be repeating until you are done. Now, we have a lot of examples. I'm going to go through those examples. But for example, let's just show you something here. Imagine, and I'm going to show you how do I replace this later. Imagine I want to find the summation of 10 values. Okay, so I can come here and say integer sum. Okay, I'll set sum to equal 0 at the beginning. And I'll say integer num. I don't know what is the value. I can come here and say cout enter a number. Okay, so I'm asking the compiler to compute the user to enter a number. I'm going to come here and say cn num. Okay, and then here I'm going to go say sum equal sum plus num. Okay, so as you can see here, I have a summation variable. I set it to 0. I have a num variable. I'm asking the user to enter that value. Now imagine I want to find the summation of 5 different values. So look what I'm going to do. I'm going to copy this. This could be, for example, the average. I'm trying to calculate your average for your grade. So I'm going to enter the number again. Remember here, the previous number that I entered was added to the sum. So for example, if I entered 5 here, 5 is going to be added to 0, so sum is going to equal 5. And then if I entered 10 here, then 10 is going to be added to sum, which is 5 is going to be 15, and so on. So let me just go ahead and do that for 5 times. Okay, so this piece of code, as you can see here, if you focus, you will see that I repeated the same exact piece of code for 5 times or 6 times, I don't know. And then I could come here and say cout sum. And actually, if I actually want to find the average, I can just come here and say sum divided by 0.5. Let me make sure that this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, so here we go, end line. So I can calculate the average, show the sum, and show the average. So you see here, this is a very, very simple example of calculating the average of a certain number of values. And you can see here that I had to repeat the same piece of code for 5 times. Okay, without using loops, you have no other choice but doing it this way. Okay, what you can do here, if you don't want to show the same message, this one, you can just say enter 5 values and then cn followed by cn followed by cn. It will work as well, but let me just run this project. And let me just switch. So here we go. I'll enter 5 and I'll enter 15. I'll enter 20. Then I'll enter, let's say, 25. And finally, I'll enter 50. And here it is. So the summation here, well, this is not right. I made a mistake here somewhere. How is that possible? Let's calculate here. 5. This is 30. This is 80. This is 100. Yep, the sum is okay, but the average is not. Let me just go and check why is it acting that way. Sum divided by 5. Oh, look at this. It's supposed to be divided by 5.0. That was my mistake. Anyway, I don't have to run it again, but I'm just showing you an example of where, again, let me just show you what is a good choice here. If I take all this away, and I'll just come here and say, repeat or 5 times. This is not repeat. Okay, loop 5 times. Okay, so I just need to put an instruction here, and I need to actually surround this block of code with curly braces. And then I'll tell the compiler to repeat this line for 5 times. And that's what the looping is all about. So you can see here, this is again a very, very simple example. I was just going to start talking about examples that we need to use looping with. Calculating any statistics, any kind of statistics you can think about, or probability calculations you can think about, it will be done using loops. You have a set of data, you're going to process this set of data to find the average, to find the standard deviation, to find anything you can think about statistics, it has to go through loops. A lot of complicated math is implemented using loop. Now, there is something called numerical analysis. Numerical analysis is like an advanced class that if you go for postgraduate studies, you may end up taking that class. Numerical analysis, basically, it's like a math for a program for computer science, which is based on how do you convert any operation in the world into a summation. Any math you can think about could be converted into a summation. And a summation is all about loops. How do you add values together? So we'll see a lot of examples during the class of today, but at this point, I just want you to know how important it is to have those looping structures. Now, we do have mainly 3 different types of loops. We're going to talk about them all. And I just want to put some rules at the beginning before I start talking about them. And the rules are, there is no looping structure that will work only in one case. Or let me just put it in a different term. There is no problem that cannot be solved if that problem requires looping that cannot be solved using any of those loops that we're going to talk about. So any problem will be given. You can solve it with the for loop, you can solve it with the while loop, you can solve it with the do while loop. So any problem that requires some looping could be solved using any of those looping techniques that we're going to talk about. But what you need to understand, one looping solution or one looping technique will be more suitable than the others. So let me put it again in this. I'm gonna give you those rules, by the way, so you just can follow them and you should be safe. Whenever you have a problem that requires looping, you should understand that any looping technique you will decide to use, you should be able to get the problem fixed and solved using that looping technique that you're gonna go with. But some looping techniques are more suitable for certain cases than the others. And I am going to give you the rules that you're going to have to follow for whenever you have this kind of confusing, and you're going to ask yourself, okay, should I use while, should I use do while, or should I use a for loop? I'll tell you, if your condition is like this, you go for loop. If your condition is like that, you go with a while loop. If your condition is like this, you go with the do while loop. So let's start with the while loop. And let me just make sure that I am following the structures in the ZY book. I just want to don't skip anything. Okay. Actually, I'm not missing anything. So let's start with the while loop. The while loop is very simple. What do you need to do? You need to start, for example, you know that you want to repeat this structure of code for a certain number of times. The while loop will start with, and remember here, I need to tell the compiler to do that. You will start with a while. That's the keyword here. And you open a parenthesis and you close it. This is where you're going to put your expression, your Boolean expression in this area. And then you go here and you put a curly brace opening, and you go all the way down here to the end of that loop and you put a curly brace. Now, here's what you need to understand about this while loop. You will say, as long as, and I want you to pay attention to this, whatever condition you will have here in this area is true, you're going to keep going with the looping process. So we need to have an expression here that will be true for a certain number of times, and at a certain time, it should be false. So you can skip and go with your tradition normal flow. So usually what we do with do whiles, now again, remember this is not a rule, but since I'm trying to find the summation of 5 entries, I'm going to come here and say integer counter and set the counter to, let's say, 0. And I will come here and say, well, you know what, let me put 1. I will say, as long as counter is less or equal 5, I want you to do this. I want you to repeat this 3 statements. So as you can see here, this counter equal 1, and 1 is less or equal 5. So that condition is going to be true. Now, because it's true, I'm going to execute those 3 lines. And then I'm going to go back. And you can see here, counter is 1. So that's going to be true again. You're going to keep going, keep going, keep going. And as you can see here, I never got to a point where counter was changed. And that's the second important part in your while loop, is that the variable that you're using here must be updated. If this value would not be updated and this condition was evaluated as true, you will end up having what we call infinite loop. Infinite loop basically means it's going to go forever. And this is some type of mistake that no matter how much you try, you're going to end up having it once in a while. So what I need to do here at this point, I need to come here and say counter plus plus, or plus plus counter, it doesn't matter. Counter plus plus basically means increase it by 1. So here's how it's going to work. You're going to start with 1. You're going to do this. And then you're going to come here and increase the counter by 1. So you go back here, and now counter is going to equal 2 because you increase it by 1. 2 is true. Repeat those lines, increase it by 1. Now it's 3. 3 is true. You can do this 3 lines. You go here, put it 4. 4 is true. You're going to go do these lines and increase it by 5. 5 is true still because less than or equal 5. So you're going to run those lines, and then you're going to increase it by 1. Now 6. When you're going to go back here, when counter equals 6, well, 6 is not less or equal 5 anymore. So the compiler will understand, okay, this is the end of the loop. Skip and get out and continue with the regular execution. Let me run it just to give you an idea. And we should get, let me see here. Come on. Okay, let me share the screen now. Let's go ahead and do the 5, 10, 20, I think 25, and I think I have 30 after that. And well, here it is. It's a little bit different, but 90, 18. You divide 90 by 5, you get this number here. So here we go. This is the program. And as you can see here, it was executed for 5 times. Now, let me just go back and show you. So as you can see here, I repeat, instead of repeating the same line 3 lines for 5 times, I just actually put them in a part as a part of this while loop, and it's going to continue until I'm done with those 5 times. So here we go. You see here, the most important part of this while loop is this counter, which basically is going to control the number of times you're going to go in that loop. Now, I know this is going to go for 5 times because I initialized counter by 1, and I said as long as it's less or equal to 5. Of course, I can actually change this to be plus equal to. That's also acceptable, but again, we don't do that usually. We just go one loop at a time. Now, this here is if I know that I'm supposed to enter values until for 5 times. Now, let me just turn it a little bit. What if I need to keep going in my summation until I enter a specific value that will tell the compiler to leave. That's the end of it. Let's see if they can do that here before I get into the details. So what I'm saying here, let me take the counter away. I don't need the counter anymore. And I'm going to rely on the value of num. And I'll say, as long as num doesn't equal -1, for example. Okay, and let's set the num to equal 0 at the beginning. Okay, so here's what I'm going to do. I'm going to come here and say sum equals sum plus num, which is basically at the beginning when we start with 0. And then we're going to ask the user to enter num, and he's going to enter it. And then we stop. We don't need this anymore. So let me just explain what I just did here. In this new version of the problem, I want you to keep going with the entering of these values. And actually, this is not going to work anymore for the average because I need to have a counter to tell me how many times I'm actually counting. I'm just going to take this part away. Just keep it as a sum for now. So I'm saying here, as long as the value that the user is going to enter doesn't equal -1, keep going until the user enter -1. That's where you're going to leave. So at the beginning, I assigned sum to 0. So this is going to be 0 plus 0. No change is going to be applied to the sum. It's going to still be 0. And then I'm going to ask the user to enter a number. And then let's say the user entered 10. Now 10 doesn't equal -1. So 10 is going to be added to sum. And then he entered 20. 20 is not -1. So it's going to keep going. And you can go forever if you want. The moment you enter -1, that's where you're going to stop the program. Of course, I can do this. I will say as long as num is greater than 0. So basically, as long as you're entering positive values, keep going. The moment you enter a negative value, no matter what that negative value is, you're going to leave. So let's just give this a try. And I want you to compare this technique with the technique that I had before. Now let me share the screen. I actually didn't work for some reason. Let's see what's going to happen. Oh, of course, I forgot. As long as this one doesn't equal, because 0 here, that's a problem. I'll just go ahead and put it the way it was. As long as it doesn't equal -1. I forgot about that part. Let me run it again. Okay, let's share the screen. So look here, I'm just going to start entering values. You can see here, I'm going. It's not going to stop. Let me put -1, and that's where it's going to stop. So you can see here, this time, I don't know how many times I'm going to repeat it. I can go from now till morning. But the moment you enter -1, that's where you're going to stop. The loop is going to stop. Okay, so let's go back to that example again. And let's start comparing this example with the example that we had before. In the example that I had before, I knew that I'm going to go for 4 times, for 5 times, for 6 times. But in this case, can anyone tell how many times I'm going to be repeating this thing? No, only me. I'm the user. I'm going to decide to stop at 100 times or 20 times or 3,000 times. So as you can see here, the while loop worked perfectly fine with both cases. When I know how many times I'm going to repeat the same thing, and when I'm not sure how many times I'm going to be doing the same thing. The bottom line, what I'm trying to say here is, while loop is used more often when you're not sure how many times you're going to be repeating the process. And we have a lot of cases that actually follow this module. For example, if you have your computer connected to a sensor, and as long as you're getting a signal from that sensor, you're going to be repeating something. The moment you lose signal from that sensor, you're going to stop doing whatever you're doing and move on to do something else. Now, this is a part where I see a lot of students get confused with. I see some students replace the while with an if statement, thinking that this is the same thing. Repeating, remember here, if you put if, that basically means if this condition is true, you're going to execute those lines. If it's false, you're going to skip and go here. But if I type while, that's a totally different story. Now, if this condition is true, you're going to repeat this until this condition became false, and that's where you're going to leave. So that's the biggest difference here between while and if statement. If statement basically means you may end up executing this block of code one time or not. While loop, you may execute this line for God knows how many times. Okay, so this is an example here. Let me see if I can find another example about looping. Okay. And you know what? I do have another example where I can actually ask the user to do something for me. Now, instead of using -1, this is what I can do. I can come here and say, let's go back here, for example, and I'll say character answer equal single quotation y. Okay. And I'll come here and say, while answer double equal y, or you know what, let me just do it a little bit, or answer equal uppercase y. So maybe the user will enter a y or lowercase y. Here's what I'm going to do. I can take this away now, and I can come here and do this. Oh, sorry, not taking that, just take the 0 away. And I'll just do it this way. Let me just cut this and put it here. Now, why are you complaining here? While answer cout error type cout is. Oh, my Visual Studio is acting weird. Okay, I'm just gonna do something here to fix this error. std : that should fix it. std. Even though I'm using the system space std, but he doesn't like it. My computer. It's a something issue with my Visual Studio. Anyway, so look at this. Look at this example here. I am asking the user to enter the name. I need to cut this from here, of course. Put it here, and here I'm going to come here and say cout. Do you want to continue? I'll say y-n. Let me put quotation here and semicolon. Of course, again, let me copy this, put it here. And I could come here and say cn answer. Okay, so look at this case. Now, in this example, previously I said, whenever the user enter a -1, that's where you're going to end your calculation. Well, what if I actually need to include -1 in the calculation? So here's what I can do. I am going to ask the user after every single iteration if you want to continue or not. And that should work perfectly fine. So let's go ahead and give this a try. Now look at this. If the user decides to go with lowercase y or uppercase y, I should have no problems. Let's give this a try again. And let's go ahead and, so my first value is going to be 7. Do you want to continue? Yes. My second value is going to be -8. Do you want to continue? Uppercase y. My third value is going to be 5. Do you want to continue? No. Now I'm going to get 4 as a value. And you can see here, I got 4 because you add those together, you get 4. And that's, again, another example of the while loop. So the bottom line of what I'm showing you here is you can use the while loop to make your program do certain things for a number of times, if you know how many times. But again, we usually, again, use while loop when we are not certain about how many times I'm supposed to repeat something. Now, again, here, remember, this answer is controlling how many times this calculation is done. Now, sometimes it's not you asking the user to enter something. It could be a data that's going to be retrieved from a sensor, or a data retrieved from a database, or a data retrieved from a website. It could be anything instead of just asking the user to stop the looping. And that's how a while loop works. Now, as I said, the bottom line is you're going to have a Boolean expression here. You start with a while keyword, you have the parentheses, and here you got the Boolean expression. This Boolean expression must be true at least at the beginning so you can get inside the while loop. And then you have the body of the loop. Every time you move from the first line in the body loop to the end, this is what we call a loop or iteration. Now, what's very important here is that you need to, there must be a line inside the code here where your variable that you're using to control the loop will be updated. If I take this part away, the part that I ask the user if you want to continue or not, I will end up having what we call infinite loop, a loop that will never end. And this is something you don't want to have. And that's mostly everything we need to know about while loops. Now, if there is any questions, let me know. And I'm going to keep going, tracing the, what they call it, the ZY book. Now, in this chapter of the ZY book, you'll see a lot of examples, which I highly recommend everybody to go ahead and have a look at them. One of them that I really, really like here is, how do you find the GCD? GCD is the greatest common divisor. So if you have two numbers, for example, let's go ahead and do that. Integer x1, let's say equals 75, and x2.
Hey, Professor.
Oh, yes.
I have a quick question. So
Go ahead.
when you do get that infinite loop, is it going to bring up a error, or is it just going to keep running that loop until you?
It's going to keep running until the program crash.
Gotcha.
Yep. Usually, it's the program is going to crash. It's not going to. There will be no syntax errors or anything. Okay. So let's go ahead here. Integer x1 equals 75. And then I'll say x2 equals 25. Or let me put it as, yeah, let's go 25. Now, the greatest common divisor between those two numbers is actually 25. It's basically what number do you have that you can divide those two numbers, the greatest number that you can have that you divide those two numbers by and don't get any remainder of a division. Now, I can come here, for example, and put 0. That'll make it 20. And if that's the case, 5 is going to be the greatest common divisor for those two numbers. Okay. So how do I find the greatest common divisor using a while loop? Well, the idea here is very simple. What we're going to do, we're going to have a while loop. And we're going to do the following. We're going to come here at the beginning and we'll say, as long as those numbers, they don't equal each other. Okay, this is an algorithm. It has a name. Let me try to remember. It's called. I don't even know how to pronounce it. It's Euclid's algorithm. Euclid's. Okay. Now, as long as those numbers are not the same, we come inside here and do an if statement, and we'll say if the second number was greater, oops, it's not typing. Okay, here it is. X2 is greater than X1. If that's the case, what we're going to do, we're going to do the following. We're going to update X2 to equal X2 minus X1. Now, if that's not the case, that basically means x1 is greater than x2, we're going to come here and say x1 equal x1 minus x2. And then finally, after that, the greatest common divisor here is basically going to be x1. So C out x1, end line. This algorithm here is just to find the greatest common divisor between those two numbers. As it should here, the number should be 5. So I do have this condition. As long as those numbers are not exactly the same, if the second number is greater than the first number, we're going to update the second number to be the subtraction the first number from it. If that's not the case, we're going to subtract the second number from the first number. Now, after that, after you're done with this while loop, whatever value that Cout will be holding will be actually the greatest common divisor. Now, what I'm going to be doing here, let me just run it. Remember, I'm supposed to get 5. I believe I should get 5 here. I'm going to skip the first one, the first part. So I'm going to say, for example, 5, and I'll say no, and here it is. So this was 5, and then here's 5 as the greatest common divisor. Now, let me just go and show you. If I change this one to be 25, I believe 25 this time is going to be the greatest common divisor. So let me just put here, let's say 11. And now it's 25. Well, I'm not sure why is it showing me this and then this. Did I make a mistake? Let's see here again. Go back. Oh, here, yep, I actually have the sum in the wrong place. Let me just cut it and put it here in this area. That was a little bit confusing, but here it is. So the sum here is going to be showing me the sum here, and that was actually 25 as the greatest common divisor. So here we go. As you can see here, this is an example of a really helpful calculation of the greatest common divisor between numbers. This is going to be very helpful in the future when we're going to be talking about operator overloading and how do you create complex operators and rational values. This function could be very helpful when we get to that point. Anyway, that's another example about while loops. So if I want to summarize what we just talked about so far, I would say while loop, it's the technique that you're going to use when you're not sure how many times you're going to be repeating the process. I just want you to look at this while loop and tell me, can you tell me how many times you're going to go here? No, there's no way you can tell. It totally depends on whatever value is going to be assigned to x1 and x2. So those two values are going to control how many times. But you as a user, you don't tell me that repeating this for 5 times or 6 times. Those two values control that operation. Now, what I'm going to be doing here, I'm going to take this part and convert it into a comment. And let's continue. Now we're done with a while loop. We can talk about the for loop. The for loop, it's another type of repeating structures where we use it a lot more when we know how many times we're going to be repeating the structure. For example, I want to process the data of the students in this classroom. I know I have, for example, let me see how many students do I have? 12. I do have 12 students in this classroom. I can make a for loop that will go one iteration for each student. I have 12 apples in my box, so I'm going to go for a loop that goes for 12 times, relying on the number of apples. So for loops usually is used whenever you are certain about how many times you're going to be repeating something. And those examples that we used here, I can use them, but it's not going to be a really good example. So let's go ahead here and try to repeat this one when I knew that I'm going to be doing 5 times this process. So I'm going to copy this portion. I'm going to put it down just to show you how do I use a for loop with it. Now, I do have the sum, I have the num, I can take this away, I don't need it anymore. And I can take this part away, I don't need this anymore. And then I don't need this anymore. And now the idea here is to ask the compiler to repeat this for 5 times. And this is how we do it. You come here and put the keyword for, and you open a parentheses. Now, inside this parentheses, we do have 3 fields. Field number 1, field number 2, field number 3, separated with a semicolon. And then you come here and you create and you initialize your counter. So integer counter equal, let's say 0. Now you come here and this is where you check your counter with the Boolean expression. And okay, let's just put it as 1. And I'm going to come here and say, as long as counter is less or equal 5. And this part is where you increase counter plus plus. Okay, so you can see here, this is my for loop. It's the keyword for loop, for. You have a parentheses, and then you have 3 portion of 3 expressions you put inside this, between those parentheses. You start with the initialization declaration of your counter. You have the comparison operator or Boolean expression, and then you have the increment or updating for your counter. And then you're going to keep repeating forever. Now, something that I forgot to talk about before. I see a lot of students, they put a semicolon in this space, and that's a big mistake. Never put a semicolon here. Same thing here. Never put a semicolon here in this area. Okay. Now, what you should know about this? You should know the following. Number 1, this line is going to be executed only at the beginning of the execution. Immediately after this line is executed, the comparison is going to start. If this comparison or Boolean expression is true, you can execute those 3 lines. When you get to this closing curly bracket, this line is going to be executed. So the structure is important to understand. At this point, counter plus plus, this is the part where this line is going to be executed at the end of your loop. This is going to be executed 1 time only at the beginning, and this is going to be executed every time you go with that loop. Now, if I run this program, I can guarantee this is going to go for 5 times. Of course, you can control how many times you want it to go. And again, look at this. I can do it this way. I can put 5 here, and I'll say as long as it's greater, as long as counter is greater or equal 1, and then I'll say here counter minus minus. This will give me exact same results. It's just that I started counting from 5 all the way to 1 by subtracting the counter, or counter from 1 all the way to 5 and increase the counter. Your chances of having an infinite loop here is very, very limited unless you make a big mistake here, but that's hard to happen. Okay, now what we can do here, one thing you should understand, which is extremely important, this here, this variable, it's called a local variable. Local variable basically means, and look what I'm going to do here. If I come here and say, show me a space and show me the value of counter, I'll get an error, immediately error. And if you put it says, I have no idea what is a counter. Well, how is that possible? You just created counter here. Well, here it is. Let me just tell you. Counter, this one, belong to this loop. As long as you're using it here in this loop, you're good to go. The moment you leave, it doesn't exist anymore. So this is what we call a local variable. It's local for this loop. It's only defined inside this loop. Outside of the loop, you cannot use it. Now, how do I fix this problem? Well, there is a fix for that. If I come here and type integer counter, and then I come here and say counter equal 1, now the problem is gone. Why? Because I created counter outside of the loop, even though I'm using it inside the loop, but now it's actually global for this for loop. It's not local for the loop anymore. So that's why I was able to use it outside. So this is very, very important to understand this variable here and the lifetime of this variable. Now, there are a lot of examples that you can think about when it comes to looping, but usually this kind of loop, we use it again whenever we are sure about how many times we're going to be repeating the same structure. Unlike the while loop, where no, I actually know that I am going to be using it when I'm not sure about how many times I'm going to be repeating the structure. Now, one thing you should know usually when it comes to for loops, and let me put this back. I'm going to put an integer here and I'm going to take this away. Usually we start counting from 0. And we usually don't include 5 here. I want you to remember this because we're going to use this a lot later. So look at this. Counter equals 0, and then 1, and then 2, and then 3, and then 4. So this condition is going to be true until we get to counter equal 4, which is still true. The moment we leave 4, we go to 5, that's where it's going to be not true. There's a reason why we do that, and when we're going to get to the chapter where we're going to talk about arrays, you will see why. So just to encourage you, I always recommend to start counting from 0. And if you want to repeat it for 5 times, make sure you don't put equal 5 here. Okay. Let's see, what do we have here? A lot of examples if you go to the ZUI book to explain. Now, I can use loops with the strings, and let me show you an example of that. If I come here and say string, and I'll say name, for example, equal Adam. Imagine I want to print the name without any digits. Okay, just imagine I want to print the name without any digits. So if I come here and say Adam 76 Smith 100. Imagine that's the name. I want to print this name as it is, but without those numbers. Okay, so here's what I can do. I can come here and say for integer I or equals 0, as long as I is less than name.length. And then I++. So this is me going through all the characters. Now, since I'm using string, let me include the header file string here. String. Look what I can do. I can come here and say character C, and let's keep it that way. I'm going to come here and say C equal name dot at I. This here will extract the characters one by one, starting from the first character, which is uppercase A, all the way to the last character, which is 0. So I'm going to go character by character, and then I'm going to come here and say if, I'm trying to remember here, C dot is digit. No, it's not that. I remember here is digit. Yep, here it is. And I'll put C here. So what I'm saying, if it's a digit, well, I need the opposite. So I'm going to say if it's not digit. Okay, remember here, is digit will check if the number of the character is actually a digit. Now, what I want the opposite. If it's not a digit, so I'm putting the not operator here. If it's not a digit, show it on the screen. C out, C, semicolon. And then after that, I can come here and say C out, end line, semicolon. Okay, this is here is just to show you I can actually use a for loop with a string. So you can see here, I'm going for the full length of that string, and I'm extracting a character by character and put it in C. And then I'm saying here, if that character is not a digit, so anything else, show it on the screen. If it's a digit, skip this line. Let's give this a try and see what's going to happen. Okay, let me share the screen. Now remember, this one is supposed to read 5 numbers, so I'm going to go 5, 5, 5, 5, 5, 25, and here it is, Adam Smith with no digits. And that's basically how for loops works. Now, as I said, if you go to the book, you'll see a lot of examples, and we have something called nested loops. And a nested loop is basically a loop inside a loop. And we use nested loops a lot in C++ and in programming in general. So let me show you an example here. If I ask you to show me the timetable of the numbers from 1 to 10, okay? From 1 to 10. I want you to show me the timetable for all the numbers. So here's what I'm going to do. I'm going to show you how do I do that. I will say for integer x equal 1, as long as x is less or equal 10, then x plus plus. Okay, so that's my first number. And here's what I'm going to do. I'm going to say for integer y equal 1, and y is less or equal 10, and then y plus plus. And here's what I'm going to do. I'm going to show you see out x multiplied by y. And then I'll put a space here. And then I'll put a semicolon here. Now, when I'm going to come here, I'm going to change something here. I'm just going to come here and say set w to 3, or let's make it 4. And then I'm going to have to include a new header file called IO manipulation. Okay. So I'm reserving 4 spaces to print the product, the protection of those 2 values. Now, what's going to happen here? X is going to be 1. 1 is going to be multiplied by 1, and then multiplied by 2, and multiplied by 3, and 4, and 5, and 6, and 7, and 8, and 9 until I get to 10. Then it's going to leave this for loop, and it's going to go back to this for loop. Now, x is going to equal 2. So 2 is going to be multiplied by 1, and 2, and 3, and 4, and 5, and 6 until you get to 10. And then after that, you're going to update x to be 3. And then 3 is going to be multiplied by y 1 to 10, and so on. What's important here is that after each line of y, you need to go to the next line. Otherwise, it's just going to be like one line. So this is supposed to be a square matrix. Let's run it. Let me share my screen. So I'm going to start with this 4, 4, 4, 4, 4. And this is my 20s, the summation, Adam Smith. And look at this. This is the timetable of 1, timetable of 2, timetable of 3, timetable of 4, all the way to timetable of 10. So you can see here, I was able to print it using this beautiful format using a nested loop. And if I go back to my code here, you can see here, the whole point here is for each value of x that go from 1 to 10 is going to be multiplied by y, which is 1 to 10. So for 1, multiply by 1 to 10, 2, 1 to 10, 3, 1 to 10. And what I'm doing here, I'm having this extra space. I'm reserving 4 spaces for each product production multiplication here. And then once you're done with one row, you go to the next one and you keep going. That's just an example of a nested loop operation. Okay, let's see, what else do we have? Now we're going to talk about, we are almost done, by the way. There are 2 elements left to talk about here. And I am going to go back to, let's say, I'm going to create a new example here. We have 2 keywords that are really, really important when it comes to let's look at this example here. So in this example here, I'm saying if it's not digit, print C. So it's going to print all these characters. Now look what I can do here. Imagine, just imagine, I'll say if C equal, let's say, what do I have? I. Of course, I have to be, okay. checking. As I'm scanning this string character by character, I'm checking something here, and I'll say if C happened to equal I. Now, we have two options that I want to discuss here. What if I want to skip I? Well, I cannot skip it here. I need to actually cut it from here and put it here. Let's go ahead and do that. So look at this. I want you to pay attention here. We have two keywords we can use with loops. One of them is called continue and the other one's called break. And let me start with continue. So what do we mean by continue? Again, there's no reason for me doing this, but I'm just imagine, okay? Just imagine. I am not supposed to print digits. And also, I'm not supposed to print the letter I, okay? Of course, I could come here and say, or, let me just put here. I could come here and say, or C equal I, and then I'll say, not true. This is going to give me the same result. But of course, I just want to show you the demonstration of using continue. Well, actually, this is okay. Let's go ahead and do this. I'll show you how do I convert this to this part later. But imagine that I don't want to see I printed on the screen. So what's going to happen here? After I read the character using this line, I'm going to compare it to I. If it happened that there is a match, I will see this continue. Continue basically means jump to the end of the loop. So whatever you have after this continue is going to be skipped and is going to come to this point. Okay, so let me just run it. So this is basically going to run Adam, and I is not going to be printed. It's just going to go to SMTH. Let me just run this so you'll see. Let me share my screen, of course. I'm going to go 2, 2, 2, 2, 2, and here, Adam SMTH. Now, let me go back and show you something. If I replace this continue with a break, that basically means skip everything. Don't show me anything. So basically, if I put break here, what's going to happen when this condition becomes true? That basically means it's going to, when it gets to the I itself, it's not going to print anything after that. It's going to skip the whole for loop. So the bottom line here is break and continue are tools that you have that will allow you to skip the whole loop or skip one iteration. Now, of course, I cannot tell you when to use this and when to use that. It totally depends on the problem you're trying to solve. Sometimes you want to skip one iteration. You're doing some process for some data, but a certain data you don't want it to be included in the calculation. Then you go break. You go continue. But sometimes you have a process. You're processing a data, and you know if you're going to have a data that's going to equal a certain value, you need to stop the whole process. So depending on the situation that you have, you're going to have to think about using a break or using a continue. Now, let me just go ahead and update this piece of code so it will work perfectly fine. Look what I'm going to do. I'm going to come here and copy this, cut it actually. Now I'm going to put it here. And I'm going to come here and say, if it's digit, continue. So what I'm saying here, after you read the character, if it happened that it's digit, continue, skip printing it on the screen. And this is a good example of using continue if you want to skip something. So basically, I'm saying if it happens that you're reading a digit, just continue, skip whatever remain, which basically is printing of that value. That's the continue keyword. Okay, now the last part, which I'm not pretty sure why is it here in this chapter, but it's okay. Let me cut this part from here. I'm going to go ahead and put it in this area here. And this is what we call the enumeration.
Hey, Professor.
Yes.
I had a question about the skip.
Continue?
Or yeah, the continue. if you wrote code after that and that if statement was false, would it skip the continue and go to the code you wrote below?
Okay, let's look at this case here. Are you seeing my Visual Studio?
Yeah.
Okay, so this condition here is a digit. If this is true, it's going to go to the continue. Continue is going to move the execution to the end of the loop.
Oh,
So
okay.
if this is true, you're going to skip this part and go here. If it's false, then you're not going to continue. You're going to continue normally.
Okay.
So basically, for example, when I'm going to read A as Adam, this condition is going to be false because A is not a digit. So it's going to show it on the screen. Same thing for D, same thing for A, same thing for M. And then I'm going to read 7. Now, when I read 7 here, 7 is actually a digit. And because it's a digit, so this condition here is going to be true. And because it's true, it's going to continue. Continue basically means jump and go all the way to the end. So basically, this line is not going to be printed.
Okay.
Okay. So enormation. What is an enormation? Now, enormation basically is a technique that we have that we can create constants and then deal with them in a different way. Okay. So how is that? What does that mean? Okay, let's take this example here. We want to create a program about the days of the week. Okay. And we know we have Sunday, we have, let's start with Monday. I don't know which one we should start counting with. I'll go with Monday at the beginning of the week. So Monday, Tuesdays, Wednesdays, Thursdays, Friday, and then Saturday, and then Sunday. Okay. What I can do this. I can say, come here and say constant integer Monday equals 0. I decide to start counting from 0. You can start counting from 1 if you want to. Okay. And then after that, of course, let me just copy this. I'll come here. I'll say Monday, Tuesday. Put 2 here. Wednesday, 3. Thursday, 4. Friday, 5. Saturday, 6. And then finally, Sunday, 7. Okay, so let's say I have a program I'm supposed to process and use the days in my calculation, and every day is going to be represented by a number. So you can see here, this is me creating 7 days of the week in 7 constants. Now here's what I can do. I can replace all these 7 lines with a declaration of what we call enum. So here's how it's going to work. I will say enum, that's the keyword, and I will call this something days, for example, days. And days is going to equal, or it's not going to equal actually. You open a curly brace and you close it and you put a semicolon. In this area, you put the following. Control C. Oops, I made a mistake. Let's just type them. MONTUEWD. Now remember, those words that I'm using, you can use anything you want. You can think about anything else. Saturday and then Sunday. Okay. And now this is basically equivalent to those 7 lines. So what did I just did here? I created days and I call it Monday, Tuesday, Wednesday, Thursday. Now here's what I can do. Let me just come here. Uh-oh. My Visual Studio decided to die on me. This happened last time. I had to restart my computer for it to work. I'll just give it a little bit of time. Let me just task manager. I'm going to shut it down and open it. Remember the project called project 61. Before I decide to do that, are you going to go? Nope. And task. Cancel. Okay. Oops. It's gone. I'm going to have to open it again. This is actually the last part of the class of today, so let me just get it over with. So I'll give you guys a break, and then you can start working on those. I think I do have a virus in my computer system. I think, I'm not sure. Oh yeah, everything's gone. All that time. Let's start again. So you can see here, everything is gone. So enum days. Remember here, you don't have to use uppercases, but because we're talking about constants, it's usually recommended to use uppercases. Mondays, Tuesday. Look at this, what's going on here? Days, again, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay, here we go. So I got this enum data type. Now what I can do here, I can say days, uppercase, D, for example, equal MON, semicolon. Okay. Now, what you should know here, now, in my program, I'm going to use D here, when D have the value of Monday. Let me just make sure that I'm not wasting any time here. Yep. So look what's going to happen. By default, let me just tell you here, by default, Monday will have the value of 0. If you don't want that to happen, you need to come here and set that to whatever value you want to start counting on. So I said Monday to 1. That basically means Tuesday going to be 2, Wednesday's going to be 3 and 4 and 5. Of course, if I come here and put 10, Tuesday's going to be 11 and 12 and so on. So let's just start with Monday is 1. Now I could come here and say, if, let's say, I'm going to change something here. I'm just going to come here and say some day. Okay. Is Monday. So I could come here and say, before I do that, let me just show you, see out some day and line. Okay. So let me run it. You will notice that since it's Monday, it's going to show me the value of 1. And you can see here it's 1. Now what I can do, I could come here and say, switch to some day. And in this area, I will have case Monday. And I will have a case for each one of them. And basically, if this someday is one of those 7 different values, then a different action will be taken. This could be a plan, a plan for your weekly activities. So that's, again, what we mean by Monday. Now, the thing is, the reason why I was like, why are you talking about it right now? Because we're talking about loops, and this has nothing to do with loops in general. But it's just a technique that we have that could help us. Now, remember here, the whole point here is to use words instead of numbers. So someday, and that someday could be a Monday, could be a Tuesday, could be a Wednesday, could be a Thursday, could be a Friday, could be Saturday, could be Sunday. If you use it this way, it's going to be a lot easier for people to understand what's going on instead of replacing those with numbers. If someday is Monday, then I'm going to go to work. If someday is Saturday, I don't go to work. If someday is Sunday, I go and play soccer or something. So that's what we mean by enum. It's a type of data that you create. You can see here that in C++ in general, there is no data type called days, but I actually managed to create a data types, and it's enum. So basically means those values are going to be constants, and they will have values. Now, of course, remember this: since I start Monday with 1, I can come here and put. Let me just go with. I could come here and put equal 90, for example. That's totally acceptable. But you should know that Wednesday is going to be 91 if you don't specify something else. And that's the end of the class of today. You guys can, there are 2 examples that I want you to go and have a look at them. They're at the end of this chapter. And then after that, you guys have the labs. I'll give you guys a break for 10 minutes. So I'll be back at 7:25. And if you have any questions, of course, let me know. I'm going to stop recording so I will be able to upload this video after the class.